Yaskawa.
Welcome to the MP2600iec Hardware Overview e-learning module. My name is Matt Pelletier, and I'm a product training engineer for Yaskawa Motion Control and Servo products. I'll start with a brief product description, and then I'll show how a whole MP2600iec system might look. We'll cover the options before diving into the technical features, such as the front panel, networking, and I/O. We thought it would be beneficial to mention the theory of operation, some programming features, electronic cam, Sigma 5 tuning, and then finally I'll show the demo box we've developed. So let's get started. The MP2600iec is a single-axis controller combined with a Sigma 5 servo amplifier, factory installed and ready to go as a single unit. You'll program it just like any of the other controllers in the IEC controller family, using MotionWorks IEC Express or Pro, which is software that's based on two global standards, IEC 61131-3 and PLC Open. When you use the MP2600iec, you're taking full advantage of the Sigma 5's advanced tuning, vibration, suppression, and safety features, and so you'll get all of the Sigma 5 performance just like with the other controllers of the IEC family. The controller offers critical I/O for many applications, an external encoder input, an analog I/O, and digital I/O. All network communication connects to the dual Ethernet ports and supports Modbus TCP, Ethernet IP, and OPC protocols. In this illustration, I'd like to show what type of system you can have with this controller. I'll start with some examples of local I/O connected to both CN1 and CN13. Most of this are things you'd normally expect: switches, sensors, relays, indicators, and also some type of analog sensor, like a temperature or pressure sensor, an analog output, either for display or to control another device, and an external encoder input, most likely an encoder on the machine, such as a master input for electronic camming and gearing types of applications. On the network now, I can connect an HMI, several Ethernet I/O devices, and even a PC application using OPC protocol. We know a lot of our customers out there are comfortable with their PLC handling the network components, so this controller will often be seen just as another device reporting to the PLC. In fact, the MP2600iec can be a master and a slave at the same time over any combination of these protocols. Having a second Ethernet port gives the controller a second IP address. You can use it with your PC at any time then to connect without disrupting the factory network. You could also use it to isolate your I/O from the HMI, one network for the HMI and another for the I/O. The ports are even auto crossover, so you can use any Ethernet cable you want, crossover or straight through. The MP2600iec does not come with any options, but rather it is an option for the Sigma 5 amplifier. So although we talk about it as a separate controller product, in reality it's part of the Sigma 5 product line. There are 29 different models of Sigma 5 in capacities from 50 watts to 15 kilowatts and in 3 different voltages. Just like the EtherCAT option for Sigma 5, the MP2600iec option is factory installed and assembled with one single part number and serial number for the unit. So when you order a new one, you'll use a single part number, and the same goes for any field replacements. Now let's get a little more technical and take a closer look at the front panel. On the left side we have the usual Sigma 5 status display. There's connections for main power to the motor and control power for the logic of the entire unit. A regen resistor can be connected at B1 and B2, and at the bottom you have U-VBA for the motor. Communications are next to that with the USB port, labeled CN7. This USB port is for connecting our free software, SigmaWin Plus, in order to fine-tune the motor. And just one note about this, the adaptive tuning, called tuning less mode, is active by default and works great. So only if you really have to squeeze out the highest tuning performance would you ever need to use SigmaWin Plus and run through the advanced auto tuning. Moving down, CN1 accesses the 26-pin I/O connector, which I'll describe later in more detail. And below that is the safety connector, shown here with the factory-installed shorting plug removed. And finally, at the bottom is the connection for the servo motor's serial encoder. The serial encoder means that specific motor information as well as position are constantly being communicated between the encoder and amplifier. If you want to find out more about the Sigma 5 motor's performance and features, please check out the Sigma 5 hardware e-learning module, and that's all I'll say about it here. Moving over to the other side of the unit, I want to point out that there is no additional power wiring for the MP2600iec controller card, and that's because the servo pack control power powers the whole unit. At the top of this side you see the status LEDs. These work the same as all the other MP2000iec controllers, with indicators for run, ready, alarm, low battery, and Ethernet status. Below the LEDs, I think you can easily recognize the two Ethernet ports, and the dip switches are below that. Using these dip switches is generally not required, since the same functions can be accessed through the software. One exception to that is that we do recommend you leave the config switch on. I've got a lot more to say about the local I/O on the big 50-pin I/O connector, so I'll save my comments. And then finally at the bottom is a small connector for the controller battery to back up the RAM. You'll need this so that the values of your retained variables are stored when the controller is powered down for an extended period of time. On the smaller servos, this does make the unit a little taller, but you also have the option to connect the battery to CN13. Since there is so much you can do with Ethernet connectivity, I want to take some time to underscore some details. As we've seen in the system diagram, each port is auto crossover detecting so that you don't need to have a crossover cable to connect the PC directly to either port. And those of you who have worked with Yaskawa's IEC platform know that the E-init switch temporarily overrides the IP address. So now that there's two ports, I'll just mention the default IP address will be 192.168.1.1 for the top port, CN11A, and then the bottom port is 192.168.2.1. That port is CN11B. I/O expansion is accomplished exclusively over Ethernet. This way you'll have access to a variety of manufacturers, such as Phoenix, Wago, and others, as we support Modbus TCP IP and Ethernet IP. And we do have e-learning modules that show how to connect a Modbus TCP IP I/O module, and another one on how to connect a PanelView Plus HMI. So please check out our e-learning videos. Ethernet communication is also a direct access point to the controller by using its built-in web interface. There's lots of troubleshooting and maintenance that you can do directly through the web interface, even if you're using a computer that doesn't have MotionWorks IEC. You can troubleshoot and clear alarms, you can test motion, set parameters, you can load a program through the Program Archive feature. You can pretty much do everything except to edit the code and monitor the code itself. OPC is yet another communications option over Ethernet. OPC is a widely used standard communication interface for factory automation. Once you have Yaskawa's OPC server software running on your PC in the network, you have opened the gateway to real-time communication between the machine process and the factory network. For an overview and demonstration of the OPC server, please check out the e-learning video. Let's move now from the network to the local I/O. I/O for the MP2600iec is accessed through two different connectors. There is CN13 on the right and CN1 on the left. CN13 gives you access to 8 programmable digital inputs and 8 outputs for connecting switches and sensors. There's also a 16-bit plus or minus 10 volt analog input, useful for temperature sensors, position sensors, and other devices with an analog voltage output. And CN13 has an analog output as well, and this output is often used to control speed of an inverter drive or to control an analog meter for application monitoring. And the external encoder input, or pulse input, is also found here on CN13. This is most often used to connect the encoder from a master axis for camming and gearing applications. And in addition to the encoder, we have a special pulse latch input, which is a dedicated high-speed input so that you can capture the position of this master encoder in very fast 5 microseconds. This way, as the product moves down the master axis, its position can be very accurately registered, and the motion or cam profile can be adjusted for accurate performance. On CN1 are 7 additional digital inputs. Each is programmable and available to the application program, but you can also set these to have automatic functionality on the servo. For example, by default, one input is for positive overtravel and another is for negative overtravel, and so these automatically stop the motor without any controller intervention. Torque limit and other special servo amplifier functions can be set through these inputs, and you don't have to do any application programming, you just set a parameter. The same goes for the 3 digital outputs. Each of these are available to the application program, but the servo can also control them directly. By default, output 1 is the output that controls a brake relay if you have a motor with the holding brake. And so again, you really don't have any programming required if you want to use holding brake on output 1 on connector CN1. The amplifier's normally closed alarm output is still available, but unlike the 3 programmable digital outputs, the alarm output is fixed. And also, we can't forget that the encoder output from the motor is available with channels A, B, and index pulse. So if you're using the MP2600iec as a master access to another controller, you will definitely need to send out the position. And as with previous Sigma products, the output resolution or pulses per motor rotation can be set to virtually any value by means of a single parameter setting. One last item to note is that the Sigma 5 safety I/O connector, CN8, is also available here. Normally you would see the included shorting plug, but you can always remove that plug and integrate a hardware base block feature, also called Safe Torque Off, as you would with any Sigma 5 amplifier. And you can find out more about the safety feature by watching the Sigma 5 Safety e-learning module, which we have dedicated to this topic. Now, to get really technical, let's talk about the input wiring polarity, commonly referred to as syncing and sourcing, or PNP and NPN. We want to promote this wiring flexibility because other products have a fixed wiring polarity, and for some markets, wiring one way or the other makes a huge difference in whether or not the machine satisfies certain regulations. So, to make it perfectly clear, let me explain using a diagram from the MP2600iec manual. The inputs to the controller can be wired as either all syncing or all sourcing. It simply has to do with whether the 2 input commons are attached to positive 24 volts or 0 volts of the I/O power supply. The input contact then completes the circuit by connecting to 0 volts for the syncing configuration or to 24 volts for sourcing. The same holds true for the inputs on the CN1 connector, and the common pin 6 can be connected to 24 volts or 0 volts, and the input switch completes the circuit. While the digital input banks are wired either all syncing or all sourcing, the digital outputs can be individually wired for syncing or sourcing, both on the CN13 connector and CN1. The first difference you notice here is that there is no common output connection. Each output gives access to both sides of the output transistor, and so this allows you to wire one output as syncing and another as sourcing, using whatever configuration is the most convenient or applicable to the device that you're connecting. You can always jumper pins together to create the common connection if you want to. For example, if you want the wiring equivalent to our LIO06 card, then you would jumper together the negative side of the outputs. On CN1, the digital outputs are wired in exactly the same way, including the alarm output. We do offer I/O cables to get at all these pins of these connectors. For the CN13 connector, we've got the 50-pin flying lead cable and also the terminal breakout box version. CN1 uses a separate connector, also the usually preferred terminal breakout box. And as you can see, both of these breakout boxes are extremely compact, so you can maximize your panel space. Let's move on now to the theory of operation. The MP2600iec controller card interfaces with the Sigma 5 amplifier over the dual port RAM connection. Let's look a little bit at how this happens. The first step is the program logic. This includes all the ladder logic, function blocks, SFC code, etc. that's executing in the different tasks in the controller. This program logic updates at the application scan rate, which typically ranges from 4 milliseconds to 20 milliseconds. But the application scan is only part of the story here, because if you see right above that, directly attached to the program logic is the profiler. And this is basically the engine that actually commands motion in the servo. And the profile updates quite a bit faster at the dual port RAM rate, which can be set anywhere from 1 millisecond to 4 milliseconds. It's these two different levels of control that guarantee smooth and precise motion for the entire system. Now let's look at some programming features. The MP2600iec can be programmed with both versions of MotionWorks IEC, Express and Pro. The Pro version adds a couple of major features, including multitasking and then the SFC programming language, and there are other numerous tools and options available in the Pro version. We have an in-depth e-learning module that covers Pro, and also a quick start video to get you up and running using Pro. I think you'll be pleased to know that there is a high level of compatibility between the MP2600iec and the other MP2000iec controllers. Program worksheets, code assemblies, and variables can all be copied and pasted between projects no matter what controller was used in that project. Likewise, function block libraries you create for one controller can be used in a project for another controller. Add Yaskawa's growing list of toolbox code libraries, and you're sure to have the ultimate in reusable code. A related programming feature is the scalability of your projects in the MP2600iec. You can scale both up and down. Scaling up means that any code you write in the MP2600iec is compatible with the multi-axis controllers. So you can literally open an MP2600iec project, change the controller type in the hardware configuration, and continue programming for a multi-axis application. Scaling down your existing multi-axis project to the single-axis MP2600iec works in much the same way. This scalability means that machine designers can create code libraries and scale their control systems to meet the level of automation the customer is able to invest in. It's one control platform, it's one software environment for both single or multi-axis. The MP2600iec is a 1.5-axis controller and servo system designed to handle a wide range of single-axis motion control applications. Really what that 0.5 axis means is that we can also read in an external encoder input. Independent single-axis motion control applications are ideal for the MP2600iec as they can be linked together through an Ethernet connection using Modbus TCP IP or Ethernet IP protocols. And remember, motion is performed using PLC open function blocks and in an IEC 61131 programming environment. Both PLC Open and IEC 61131 are an international industry standard for programming machine controllers and PLCs. One common application for the MP2600iec is point-to-point indexing using the PLC Open function block MC Move Relative or MC Move Absolute. Due to the tight integration between the MP2600iec and Sigma 5, you can get really fast positioning. For example, we've seen a 72-degree move in 14 milliseconds on a machine with a directly coupled load and 1-to-1 load-to-motor inertia ratio. Another common application is absolute rotary indexing. Dial tables for automated assembly oftentimes require this absolute feedback to ensure recovery of the system from a complete plant power loss without rehoming. A third type of application is velocity profiling. And velocity profiling means running a rotary or linear motor at different speeds and then blending the speeds through defined accel rates. It includes any application that requires move profiles defined by speed, acceleration, and distance. One example of a velocity profiling application is a centrifuge used for medical applications. It is also possible to do speed-limited torque control very easily using the MC torque control function block. This allows for easy programming of applications such as bottle cappers, which torque down caps to specified torque level. Speed limiting is simply a setting input to the function block that prevents the servo from running away to high speed while not in contact with the cap or when external load is not present. Electronic camming is a huge strength of this controller, and so I'd like to take some time to go into that in some detail. First of all, an overview. If you're not familiar with what electronic camming is, electronic cam moves the servo motor based on the position of a master axis. and this ensures that the motion is synchronized. There are two basic types of electronic cams. You see out there, linear and rotary. Linear cams move out a given distance and then move back, whereas rotary cams just keep going in the same direction. One example of a linear cam application is the die cutting machine, as you can see in this animation. The motor at the top right in the animation moves the cutter back and forth, and so that cutter has to remain synchronized with the label when it's cutting. One example of a rotary cam application is a plastic wrap sealing machine, which you could see illustrated when you go to the next page. And with a rotary type of cam, a rotating knife may have to slow down or speed up at different phases of its rotation, and then it always needs to remain synchronized with the plastic as it moves. Yaskawa is well known for its electronic camming capabilities, especially in the high-speed packaging machines that demand increased throughput without sacrificing accuracy and yield. Other camming applications will include feed-to-length, linear flying shear, random rotary placer, and rotary knife. Camming is highly recommended for these types of applications because of the flexibility, ease of use, and performance of the built-in Yaskawa camming functions. Camming features in all of the IEC controllers are executed at the firmware level in the controller so that the motion profile performance will remain fast even if your application scan goes up. Single-axis camming is ideal when the motion must be actuated in relation to other motions on the machine. Even simple point-to-point applications can benefit from camming because the motion will stay synchronized. This synchronization will be maintained even if the machine's cycle rate goes up or down. And this is because with electronic camming, the servo doesn't move based on time. It moves based on the position of the master signal. Electronic cam allows the option for a very complex motion profile so that you're not limited to the standard trapezoidal moves, but can take full advantage of algorithms that produce smooth motion. We have lots of resources for electronic camming, including Cam Tool utility and the Cam Toolbox code library, so that you can generate cam tables, either a static cam table with Cam Tool, or the controller can generate the cam profile very easily using the Cam Toolbox code library. Virtual axes are another powerful programming feature in the MP2600iec, and the virtual axis is often used as a master axis so that complex motion profiles for the real servo axis can run as cam profiles tied to this virtual master. Any cam profile, whether it's based on a virtual axis or a real axis, can be further manipulated by altering the cam profile using techniques called scale, shift, and offset. If you're interested in learning more about electronic camming and scale, shift, and offset, we do have an e-learning video that demonstrates these camming basics. Let me quickly describe several types of machines that commonly use the application functionality we just described. Robotic loading is a single-axis point-to-point indexing application that requires variable set points sent from an HMI recipe or PLC process. Diverters or ejectors may require high-speed indexing actuated from a PLC with an Ethernet command or with I/O handshaking. Material feeders or press feeders could be controlled using camming with registration in order to adjust due to material slip. And in this case, the motor indexing the material can be synchronized to the master cycle using a cam. The cam profile can be developed to limit jerk and provide the smoothest path, and it's calculated on the fly depending on changing conditions or timing delays in the machine or system. Camming is also ideal for intermittent form fill seal machines, and single-axis servo systems also work well for new automation cells added to upgrade an existing system. Interfacing is performed either by I/O or network, depending on the information needed. Labeling, random placers, perf cut stations, and sync belt type machines can be automated using single-axis motion controllers such as the MP2600iec. One of the greatest advantages to the MP2600iec is that you're automatically taking full advantage of all the Sigma 5 performance and tuning features. Out of the box, you'll be operating with our tuneless function, which has worked wonderfully for a large percentage of our customers. This is an adaptive tuning algorithm, so there's no parameters to set, and you're guaranteed to have stable, identical performance regardless of the load inertia, even if the load inertia changes. The tuneless mode is designed for load-to-motor inertia ratios of up to 20:1, but we found that many of our customers have even seen great results with the ratios several times higher than this. Typical positioning time for tuneless mode is in the range of 100 milliseconds to 200 milliseconds. If you have a fixed mechanical system, even a lower settling time can be achieved when you use the advanced auto-tuning function. With the advanced auto-tuning function, the motor will go through a series of moves and automatically fine-tune about 20 parameters. You can also set up a customized move sequence if you have a special application such as a non-reversing application or another application with limited motion. When advanced auto-tuning is finished, it's not uncommon to get position settling times down to 10 milliseconds and below. Even 0 millisecond settling time. I've seen that several occasions here at headquarters when we do the Sigma 5 applications class and we go to the tuning lab. A lot of those machines we can get down to 0 milliseconds on a ball screw or belt slide system. So take a look at the Sigma 5 tuning quick start video to see how easy it is to tune a complex system with advanced auto tuning. A separate tuning feature in the Sigma 5 is vibration suppression, so that when the motor stops, there's almost no low frequency oscillation of the load. This is especially useful when you have large machines or other systems that are not very rigid. Anti-resonance control is another filter that keeps the motor quiet when it's moving, and there are 2 notch filters that automatically are set and destroy any resonant frequencies. It's quite amazing. We offer a full function MP2600 demo unit with just about every possible I/O connected and easy access to terminals for any I/O that's not. Highlights of this demo include a ProFace HMI, a new style low-profile 40,000 count hand pulse generator wheel, an analog output digital display, and both the HMI and the controller come pre-programmed, so you can turn on the power and start to play. Or you can connect to either of them and create your own programs. On the other side, the Ethernet cable comes securely fastened to the demo, so you won't lose it. And we've also included the multi-disc inertia wheels for the motor, just like the standard Sigma 5 demo, so that you can simulate having different loads on the motor. Look for a USB flash drive in your demo that's loaded with software, project files for the demo, e-learning modules like this one, and other technical or promotional material. And we're even including a fully licensed copy of MotionWorks IEC Pro and even the OPC server software. All said, I think this is probably the most complete demo case we've ever offered. I'm going to wrap up this e-learning module with a little simulated question and answer based on some of the questions we've commonly heard. These are the topics: full closed loop, relative cost, dip switch orientation and function, CN3 serial port and digital operator, serial to Ethernet converter, MP940 retrofit cable usage, programming differences including EN, ENO, and the final feature, the precise scan time monitor. So the first question, is the full closed loop option available with the MP2600iec? You may have noticed that the Sigma 5 part number does not include the full closed loop option, so the quick answer is no. If you're not even familiar with what this is, full closed loop is when you put a linear encoder on the actuator to precisely measure the load position instead of relying on the motor's encoder. You can see this highlighted in red here in the graphic. Notice that this interface requires a connector and therefore a small circuit board, factory installed at the bottom of the option interface area. With the MP2600iec, the simple fact is that the circuit board occupies the full option card area, and so there's just no room left for the full closed loop connector or circuit board. You will see the full closed loop option available with simpler boards like the EtherCAD option board, since that's small enough to leave room for full closed loop. But since full closed loop is not a common option in the USA market, we really don't expect this to be a limitation for the MP2600iec. But should you have an application that requires full closed loop, remember you can still use one of the standalone controllers in the MP2000iec family and order the full closed loop option on your Mechatronic amplifier. What is the cost of the MP2600iec option compared to the other controllers? This chart kind of lays out here the price and performance, and you see the additional cost of the MP2600iec option is roughly 1/2, 0.5 of the 4-axis MP2300siec. And you can see in this chart that the additional cost of the MP2600iec option is roughly 1/2 the cost of the 4-axis MP2300iec, and then also up there at the top, the highest performance controller and highest price is the MP2310iec with a cost ratio of 2. I had mentioned that the dip switches are for the most part optional and that the software can accomplish the same function, but a lot of times the question is, what do those little dip switches do anyway? Let me just go through them here. Starting at the top, switch number 1, stop, will keep the program from running, and this can be useful if you want to troubleshoot and move the motors manually through the web page or through the hardware configuration. The program can also be stopped in MotionWorks.ac, and you need to stop the program so that when you try to go in and move the motors, the program's not fighting with you and trying to stop the motors or turn the servos off. The SUP is for supervisor mode. This is a mode which is used only when you upgrade the firmware. We don't recommend upgrading your firmware once the equipment's in the field, but if you do have a controller you need to upgrade, you really don't need to use the SUP switch. Supervisor mode can be enabled through the web interface by the click of a mouse. Init is an easy one. This is for factory use only. If you turn it on by mistake, no big deal. Just turn it back off. The config switch is useful when you're first setting up a machine because it will detect the servo pack and motor information. This is the one switch you'll want to leave on all the time so that the controller card can communicate correctly with the amplifier. We did mention the init temporarily overrides the IP address of both Ethernet ports, putting them to their default. And conversely, when you turn that init switch back off and cycle power, the IP addresses just go back to what they were before. And since you're paying such close attention here with the zoomed in photo, you probably see that there is a unlabeled switch 6 which has no function. What is the function of CN3? CN3 is standard on all Sigma 5 amplifiers, and it's designed for use with the digital operator. Now, about the only reason for the digital operator on a servo pack which has the MP2600iec option would be maybe to execute the advanced auto-tuning function without using PC and Sigma Win Plus. But really, this is just more difficult and more expensive than using the PC and our free software, Sigma Win Plus, which connects through the USB port right below that on CN7. So while technically in our documentation they often refer to this as the serial port, please recognize that it is just a serial port for the digital operator. There is no connection through the serial port to any of the controller variables or the program. Instead, the CN3 exists on this option style base amplifier just so that it's available for the simpler option cards that may require use of the digital operator. The next question is, how can existing serial devices be used on an MP2000iec system? And this question really applies to the entire MP2000iec family of controllers because they're all based on Ethernet communication. If you have to use devices that are serial communication based, such as an existing HMI, then your best option is to use a commercially available Ethernet to serial converter. One example of this is the Digi1 IAP serial to Ethernet converter. We've tested this particular converter and have a document on the setup in an application note. Can the existing I/O cables on an MP940 retrofit application be used with the MP2600iec? Please note that while the pinout is similar on the MP940 and the MP2600iec, the cable and breakout terminal are not the same. The improvements to the controller I/O, such as the analog input and output, the backup battery, individual syncing or sourcing inputs, none of that existed on the MP940. So while under some circumstances it may be possible to modify an existing MP940 I/O cable to use with the MP2600iec, there are factors to consider such as the twisted pair wiring, and that's really outside the scope of this e-learning module. So if you have a retrofit application and it's just really critical to retain the existing I/O cables, please give us a call at 1-800-Yaskawa and discuss that with one of our application engineers. Are there any programming differences in the MP2600iec versus the other IEC controllers? While cross-controller compatibility is the rule within the IEC controller family, there is one difference, and that is the EN/ENO option on functions. I've got a little example here to the right that shows how to use the jump instruction to accomplish the same as the EN/ENO inputs and outputs. Keep in mind that this only affects the programs previously written for the MP2300s-IEC or MP2310-IEC that use the EN/ENO option. It in no way affects the upward compatibility for code you create in the MP2600iec to be used with the multi-axis controllers. A second difference is not really a difference, but rather a new convenient method of sending CAM tables to the controller. This new option is found in the hardware configuration. It's available for all the controllers. For more details on any of the differences, our partners can view the TechNote link I have here, MP2600iec Programming Notes for MP2300s-IEC users. Another difference with the MP2600iec that's not really a programming difference, but it's a nice detail to know, is the precise scan time monitor. Because you can get scan times in the MP2600iec down to the microsecond. And this makes it perfect for optimizing your application cycle time in Pro, because you can graph the scan time in the logic analyzer as the program runs, and then you can see how the scan times change dynamically as the program executes and adjust your scan times appropriately. This concludes the MP2600iec hardware overview e-learning module. I wish you the best in your endeavors with the MP2600iec, and remember, you can always contact us by phone, website, or email for further information.